Welcome to Lead Programmer. Today we are going to look at the question single cycle check. The input is given as an array of integers, and each integer in that array represents a jump, and jump wraps around. What this means is consider this array. When we are at this position here, the value at that position is 1. And being at this position means we can jump by 1. Jumping by 1 means moving forward by 1. So being at this position, we can go forward by 1, which is we can go from index 0 to index 1, or the first position to the second position. Similarly, being at this position means we can jump by 2, which means we can go to the last position over here. Similarly, being at this position means we can move forward by -6. Moving forward by -6 is the same as saying moving backward by 6. So let's try to move backward from here. So we start jumping back. This is the first jump, the second jump, and now we realize we are at the beginning of the array. There's nothing to the left of it. In the question, it's given that we can wrap around, which means for the third jump, we would reach the last element over here. So let's start again. The first jump, we reach 2. This is the second jump. The third jump, we wrap around to the last element. Then this is the fourth jump, the fifth jump, and finally the sixth jump, which leads us to the first element over here. Similarly, moving forward by 3 would mean we would first wrap around because there's nothing to the right of 3, so we reach the index 0 or the first element. So that's the first jump, then the second jump, and the third jump would leave us at -6 or the third position. So that's the meaning of jumps. Now the objective over here is to return true if a single cycle occurs. What does it mean for a single cycle to occur? It means that starting at any index in the array, when we follow the jumps as explained earlier, every element would be visited exactly once, and we would end at the same position that we started. For instance, considering this array, we see starting at any index. So let's start at the first index. We would see we start at this index. We jump by 2. So we would reach here. Then we jump by 1. We reach here. Then we jump by -4, which means we would go over here 1, 2, 3, and wrap around to the last element. So we would reach here, and then we would jump by 2, which means we would end up over here, and then we jump forward by 3, which means we would end up over here, and finally we go back by 4 and we reach the starting position. As you can see, each element was visited exactly once, and it formed a cycle. The cycle being from 2 to 1, then to 4, then to 2, then to 3, and then to -4, and then back to 2. And this is a cycle. It can keep happening. So hence we return true in this case. Now this would also the same thing would happen if we start at any other index. Let's say we start at 3. Then in that case, after 3, we'd go to -4, then we would go to 2, then 1, and -4, 2, and go back to 3. It's a cycle. Start anywhere, you would have to reach at the same position. Now, this kind of leads us to the algorithm of how we would implement this, right? One way is to say, okay, so I want to form a cycle. That cycle should have all the elements from the array, which means starting at any index, I just need to go, I need to jump the number of times equal to the length of the array, and I should reach the same position that I started, right? So while we get ourselves thinking with that logic, let's look at an example which does not work out. So let's look at this example. Here we say let's say we start at the first element. So we would jump by 1, And then we see a negative one, so we would jump back to the first element. Now you see we form a smaller cycle here. The cycle does not contain all the elements of the array. That's why we would have to return false, even though it goes back to the first index. Starting anywhere else, we wouldn't form a cycle. So let's say we start at this particular index. We would just stay here. There wouldn't be any jump. Or let's say we start at this particular value. Then we would jump by 2, which means we would end up over here. And then again, we are stuck in a cycle over here, right? So this kind of gets us thinking, okay, so we want our execution to run for the length of the array number of times. At the end of that, if we find a local cycle, then most probably we wouldn't return at the starting position. So if that happens, we can return false. Another case is, okay, let's say we return to the starting, or the other cases, we do not return to the element where we started. In that case, we would return false as well. And if there is a local cycle, then it wouldn't be possible to return to the starting element. And that's the algorithm. So just to sum it up, let's look at the code first. So in the algorithm, let's say we start at index 0. We can start at any index. We want the cycle length to be to have all the elements of the array. So we can pick any index over here, but I chose to start at 0. And we said that we would execute our code the length of array number of times, because the cycle has to be the length of array big. And at the end, we said that after we run for the length of array number of times, if we reach the starting position, which is if the index becomes 0, then we return true. Otherwise, we know something has gone wrong. There's probably a local cycle or something else is wrong, and we return false. Okay, now what happens during each step in this loop? In that we would have to update our pointer value. So if we start at this particular index 0, then we would have to look at what is present at that location and increment our pointer by that value. Now you might be familiar with an arithmetic operation called modulus, which is basically an operation that returns, when two numbers are divided, it returns the remainder of those values. So let's say we have 3 modulus 2. So we know that when we divide 3 by 2, it would exactly go 1 times and leave a remainder of 1. So 3 modulus 2 would hence be 1, which is the remainder. We can use that logic to our favor, and while updating the pointer, we say, okay, whatever the pointer value is, we want to increment that by the value which is present at that particular index. Hence, we get pointer plus array at pointer. And to account for the wrapping logic, which means if we overshoot, we want to go back within bounds, we use the modulus operator. So let's say in a particular case, we overshoot by 1, then the length of this particular array is 4. So if we overshoot by 1, we would reach 5, and then 5 mod 4 would give 1, which would tell us, all right, I reached, well, this would actually be so this value instead of 5 will be 4 if we overshoot, because we are looking at indices, and then it'll be 4 mod 4 equals 0, because Index 4 does not exist. This is 0, this is 1, this is 2, this is 3, and this is 4. 4 mod 4 would give us a 0, which means we would have to wrap around to the first position. And we follow a similar logic with negative values. Hence, we have this line over here. Coming to the next line, we see we again mod this value by the length of the array, and that is to account for the case where uh, the pointer value might become negative. So if the result of this operation results in a negative value, then in order to handle that case, we would mod the pointer value again by the length of array, so that it gives us something which is within the bounds. Then we make a check that if at any point the pointer value becomes 0 and we did not reach the last execution cycle, then we would have to return false. There might be a loop, but the loop might not contain all the elements of the array. Hence, we would have to specially account for that case and return false. So we do not want our algorithm to return true for a loop which does not have all the elements, even though even though the loop might end at 0 for the last element. So let's say we have an array of size 10, but then the loop contains 5 elements. So it's possible that at the end of execution, we still end at index 0, but we would have completed 2 loops instead of 1 loop of 10 elements. So we have to account for that case as well, and hence we have this particular statement here. So that's the logic.